Welcome to this presentation of the Pascal Analyzer family of products. We will discuss Pascal Analyzer and how it can improve your development process. Pascal Analyzer is a tool for static code analysis. According to Wikipedia, static program analysis is the analysis of computer programs performed without executing them. Static code analysis is an old concept in the software industry. A well-known tool for static code analysis is Lint for the C language, which was introduced back in 1978. Code analysis helps you understand the code structure. Also, it can check how well the code follows code standards and conventions. Maybe the greatest benefit of code analysis is that it can find possible errors and anomalies, and also point out where your code can be optimized and simplified. Simplification normally leads to code that is easier to maintain. Imagine that you have a code base of tens of thousands or even millions of lines of code that is constantly changing. How much work would be needed to review the code manually? A static code analysis will do it for you in seconds or minutes, and you can repeat it as many times as you want. You can also compare results between previous and current analysis. This is the reason you need a static code analysis tool to simplify your developer life. Pascal Analyzer is a standalone Windows program for analyzing Delphi or Object Pascal source code. It was first released back in 2001. All Delphi versions from Delphi 1 up to the current Delphi 12 are supported. Even older, pre-Delphi code, Turbo Pascal, is possible to analyze. There is also a command line version of Pascal Analyzer, which comes in handy if you want to integrate code analysis with your build process. Or maybe you've got a lot of projects you want to analyze regularly. It is then quite easy to create a batch script to analyze all projects. Results from code analysis are presented in reports. These can be produced as plain text, HTML, or XML. Normally, plain text is sufficient, and it is easy to read and to open in other programs. If you want more control over formatting, HTML is a good choice. You can then fine-tune the display to your liking with style sheets, CSS. If you want to do your own further processing of the results, XML is your format. Pascal Analyzer's results are extensive. There are currently 53 reports. Many of the reports are divided into sections, analyzing different aspects of the source code. With settings, there is complete control of which reports and sections that will be generated for a particular analysis. There are two main types of reports. There are reports that try to find errors and problems in the code. This is similar to Delphi's built-in compiler hints and warnings, but going much further. Furthermore, there are many different reports that describe the code base in various ways. For example, you can produce a call tree, which shows how your functions interact. Or you can get a cross-reference report, which tells you where identifiers are read and set. One report focuses on lists and uses statements and can tell which units that can be removed or can be moved from interface to implementation uses lists. These reference reports are valuable, both if you've been working on the code base for years or are just getting started with code written by someone else. We will soon take a look at some of the reports with concrete code examples. You can view the reports inside Pascal Analyzer itself, and also edit source files in the built-in editor. It is even possible to use an external viewer or editor. Alternatively, there is a link to RAD Studio. When you have set up the link, it is possible to double-click on an item in a report and get the corresponding source file opened in the ID and focused on the offending code line. Analyses can be organized in projects' PAP files, each with different settings. Here are some report examples. The strong warnings report displays warnings that are considered extra alarming and requiring attention. Here is an example from one of the sections. In this rather artificial example, an SDWA4 warning will be given for ARR. The reason is, of course, that the variable IDX may contain an invalid value when evaluated in the last if statement. In the next example, the object obj in mainproc is set to the result of a call to getObj. The problem is that getObj might return nil, which makes the following call obj.my method potentially invalid, and would probably result in an access violation. In this example, it is very possible that the end condition for the second for loop is wrong. Most likely it should be written as L.count-1. This code will, because of this, trigger a SDWA7 warning. The warnings report is one of the central and biggest reports. It displays possible errors and problems in its 63 sections. Here is an example. What is wrong in the example above? Well, of course, the variable sum is never initialized. It is a local variable kept on the stack and will contain a random value at the start of this function. This code will trigger a warn7 warning. The remedy is to add sum is assigned to 0 to the beginning of the function. In this example, the parameter initial does not need to be passed as var, because it is not changed in the function. You should check that the code is correct and remove the var specifier. In the next example, the destructor in tChild class does not call its inherited destructor. The object will not be destroyed properly, which at least will result in a memory leak. There should be a last line, inherited destroy, in tChild class destroy. Here, the result variable for the function getSum has an undetermined arbitrary value in one of the possible code paths. This is when its valid returns false. Normally, you should always initiate the result variable at the beginning of the function, like adding result is assigned to 0 to the very top of the function. This will initialize the result variable. One more example from the warnings report. What is the problem in this example? The if condition is short-circuited because of the trailing semicolon after the keyword then. The code in the following block will thus always be called. The resulting value from the function will just be wrong. Not so hard to spot if you look closely at the code. But imagine finding this problem among thousands of lines of code spread over hundreds of units. And consider also a code base that is evolving all the time, so the code must constantly be rechecked. The optimization report displays possible optimizations for the source code. In this example, OPTI1 is reported for the parameter input because for performance reasons a reference-counted string should be passed with const. The recommended solution is to rewrite the parameter as const input :string. The function calculated in this example is marked with the inline directive. It is called from the function estimate. The problem is that the implementation of calculated is in code further down. This means that it will never be inline for the call from estimate function. There is an easy fix for this, and it is to move the implementation code for calculated so it is above the estimate code. The reduction report displays, for example, unused identifiers. In this simple example, redo4 is reported for the variable IDX because it is set and used once. The code reduction would be to write the if condition as if random of 3 equals 3 instead, thus eliminating the need for the variable. Sometimes, there may of course be reasons to use a variable this way. for example, to simplify the code and to make it easier to understand. In this example from the reduction report, class fields are initialized in the constructor. Those fields are automatically zero initialized when the object is created, so there is usually no need to include this code. These lines can be removed. The memory report displays different kinds of memory issues. In this simple example, the object L has an unprotected call to free. You should use a try finally block to make sure that the object always will be freed. If it is not freed, the result is a memory leak. Here are some of the other reports. The cross-reference report displays for each identifier all locations where it is referenced, read, or set. The call tree report displays hierarchical call trees. It allows you to see how your functions and procedures are called. The clone report tries to identify similar sections of code so you can simplify your code, like for example merge similar code into a common function. This really useful report analysis uses statements. Among other things, it points out units that can be removed from the list or that can be moved from the interface to the implementation uses list. The benefits from removing and moving units this way are several. One is that compilation will run smoother and quicker. Another is that the code will be easier to maintain and extend when removing dependencies of other units. It will also avoid problems compiling due to circular references. And now time for a demo of how Pascal Analyzer works. We have just started Pascal Analyzer, and this is the main window. From the menu, we select a new Pascal Analyzer project. In this dialog, we set options for our project. First, we select which code to analyze. We pick a Delphi project. It does not matter if we pick a DPR file or a DPROJ file. You should almost always select all files. On this tab page, we can select which reports to generate. This time, we stick with the defaults. For many of the reports, it's also possible to select which sections to include. On the next tab page, Format, we can choose between text, HTML, or XML. The Parser tab page is important. Here we select our compiler target, in this case Delphi 12 and Windows 64 bits. We can also specify which identifiers to exclude from the reports. Here we exclude RTL/VCL code plus third-party code. We press Run to start and are prompted to save the project. The analysis has started and we have to wait. Most projects take up to a few minutes to run. The analysis is already done. In this case, it ran in just 4 seconds. On the right side, we now see the status report, which contains details about the analysis. In the left frame, we click on the Strong Warnings report, and then we double-click on a warning. This opens up the editor window. If we right-click on an identifier, a pop-up shows where the identifier is referenced. In this case, we get an index error warning. This is because the index in lowest can have the value 0, which is out of bounds for the array. We take a look at the user's report. For example, the report shows that the unit Peganza.datetime_utils can be moved from the interface's uses list to the implementation uses list. Here is the interface uses list for the module. And this is the implementation uses list, as mentioned earlier, so we can move Peganza.datetime_utils to this location. It is possible to edit the code here, but we must remove the read-only protection first. This concludes a short demo of Pascal Analyzer. Back from the demo, apart from Pascal Analyzer, there is also its younger sibling, Pascal Expert. Pascal Expert is a subset of Pascal Analyzer. It contains the reports that point out possible errors in your code, but not the reference reports that help you understand your code base. Pascal Expert is not a standalone Windows program. Instead, it runs inside the RAD Studio IDE as an Otopi plugin. The analysis can be executed inside the RAD Studio process or in an external process. The latter option is a recommended way because it will not disturb the IDE. Results are available right in the IDE, and double-click transfers to the corresponding code location. Pascal Expert can be installed in all RAD Studio versions from Delphi 2007 and upwards. Pascal Browser is the third product in the family. It is a Windows program that parses your code and builds HTML documentation. This makes it possible for you to browse around in your code in an easy way with the hyperlinked HTML documents. This is, for example, great for letting new developers get acquainted with an existing code base. Pascal Browser, just as Pascal Analyzer, comes in 64 bits and 32 bits versions. Pascal Browser can also create superfast CHM files, Microsoft-compiled HTML help. To be able to create CHM files, you must first download the free Microsoft HTML help workshop. There is, just like for Pascal Analyzer, also a command line version of Pascal Browser to let you generate documentation in your build process. If you are interested in learning more about Pascal Analyzer and the other products, these are some useful internet links. For example, you can view the entire documentation for all products online. You can also download the documentation as PDF files. Also note that there are trial versions for all the products. These are somewhat limited, but will give a good view of the capabilities. There is also a blog with articles that may be interesting for a Delphi developer. Thanks for watching.